System of equations. We're on the first page of the notes. We're going to go down to the bottom first. It says a blank. That is a system of equations. A system of equations is two equations comprised of two related variables x and y. The solution for the system of equations is the point or set of points where the two lines intersect. The different possible solutions can be seen in the alignment of the two lines when graphed on a plane. There are three different outcomes. One solution, infinite solutions, and no solutions. So if we scroll back up, there's an example of how those three examples look. In the first picture, there are two lines that intersect at one spot. That intersection is the solution. So this is one solution. And that solution is x comma y. If you notice the next one, there's an arrow here, but then there's also another arrow there. That is two lines. One is laying on top of the other because there are infinite solutions. And another way to say that is this fancy R, that's called a double bar R, and that means all real numbers. And if you look over here, this is two parallel lines. They never touch, which means there's no intersection, so there are no solutions. And this little symbol just means no solution. Okay, so now we're going to go to the next slide where there are some examples. It says graph each equation and find the point of intersection. So if you notice, I'm going to assign the blue dots to this equation. So I'm just going to start with the y-intercept. This y-intercept is -4. So I'm going to bring my blue dot and I'm going to put it at -4. And basically my slope here is 1 because there's no coefficient in front of the x. So that means every time I go up 1 over 1, there's a dot on that line. Up 1 over 1, up 1 over 1. And I can continue that. And I'm just going to spread my lines out a little bit so that I can see where they go. So it's up 1 over 1, 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 up 1 over 1. And right there, I'm going to put another one. If you're doing it on paper with a pen, you could literally put your dots on your thing. So we're going up 1 over 1 because the slope is 1. So that's rise over run, 1 over 1. You could literally put a point every time you go up 1 over 1, up 1 over 1, up 1 over 1. So you have a line here. Going through all of those dots. The next equation is y equals -x plus 10. So I have a dot at +10 because my y-intercept is 10. And this time there's a negative in front of that 1, or that's like -1. So that means you're going to go down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1. And I can grab my dots here, put 1 at the y-intercept, and then 1 here. And if you notice, those two are overlapping. That means that this point right here is the solution of my equation. And I can also do this exact same thing in the calculator. You'll notice right here are the steps. It says find the intersection on calculator. Step 1, go to graphs. So I'm going to pull up my calculator. So and I'm going to go to the home screen and I'm going to click on graphs. Remember, graphs is this one right here with the funny looking U on it. So we're going to click on graphs. It says enter the first equation. The first equation is x minus 4. So I'm going to type x minus 4, but do not press enter. You want to press the down arrow because this is the first equation. That's why it says f1x. We're going to arrow down. See, it says f2x. That means the second equation. The second equation is negative, so I'm going to push the negative x plus 10. Now that I have both of my equations there, I can press enter. And as you can see your graph just like we drew it earlier. It says zoom out if needed to find the point of intersection. Because we can see the point of intersection here, we don't need to zoom out. Click menu and then analyze graph. It's that number 6 right there. And if you notice, there's several things, but number 4 is intersection. So we're going to go menu and then analyze graph and then intersection. It's going to give you a dotted line and you can drag it around if you need to. Basically, what you're going to do is you're just going to put it to the left of the intersection and click your mouse pad. And then when you move again, you'll notice it's making a rectangle. The only thing you have to do is make sure that that rectangle includes the intersection. So that intersection right here must be inside that rectangle. So you could go this way, but the calculator is not going to see an intersection unless you have that rectangle around that intersection. So I'm going to bring it over to the right and I'm going to click my mouse pad again. And if you notice, it says 7,3 right there. That's your solution. And it even made the point like bold and black for you there. So 7,3, that is your solution. So we're going to go back to our handout of our notes and type 7,3. And that's what we got when we did it here, 7,3. If you go to example 2, it says graph each equation and find the solution. Be very careful when you're using your calculator for these graphs. You can go in and edit your equations, but it's actually easier if you just click Control W and clear out your calculator, because if you take a chance and you accidentally leave something in there, the line will not go away and it'll throw off your answer. So it's better if you just Control W each time and then go back into graphs. And so once we do that, then we're going to type our first equation. And our first equation is 1/2 x. So we have to make that fraction by doing Control Divide. Type your 1 and then arrow down and your 2. And then notice I'm going to arrow over to the right. That's to get out of the bottom of the fraction. I don't want to be in the bottom of the fraction anymore. So it's 1/2 x. So I'm going to type the x and then minus 6. Enter. No, don't enter, sorry. Down. And then from there, I'm going to type another fraction. Control Divide. And on the top of that fraction, it says 2x minus 24. So 2x minus 24. Then I'm going to arrow down to the denominator, and I'm going to type 4. And now that I have my 2 equations, I can press enter. And if you notice, now you only see one line. If you want to double check to make sure you did it and you want to zoom, you can go to menu, and then number 4 is window zoom. And you can either say zoom out or you can say zoom fit. Zoom fit will try to fit your data, or you can just zoom out. When you press zoom out, it's asking you where you want the center to be. Typically, we want the origin to stay in the center, so I just put my little magnifying glass over the center and then just click the mouse. If you notice, both equations are actually there, one on top of the other. And if you're not sure, again, you can check it this way. Press Control T, and that table will pop up. And if you notice, here are your x values. If you look at your y values for both equations, they're here. This is equation 1, this is equation 2. No matter which way you arrow, you can arrow up. They're all the same. Equation 1 and equation 2, they're in the same place every single point. And you can arrow down and double check too for a few. They're the same every single time. What that means is you have one equation lying on top of the other. So for our notes, and we'll actually pull the calculator back up for a second, and we will get a couple of points. We have this point here, which is Control T. If you look at where x is 0, it's at -6. And then we're going to say, okay, at 4, it's at -4. So we have 0, -6. we can put a point at 0, -6. And actually, both equations are at 0, -6. And they're both at 4, -4. So go right from the origin, go right 4 and down 4. 4, -4, and 4, -4. We have one line overlapping over the other. And that means there are infinite solutions. Okay, we have one more example for you today. It's these two equations here, 1/2 x plus 3 and 1/2 x minus 2. So I'm going to go to my calculator and I'm going to press Control W, say no to saving, and then I'm going to go back to graphs. My first equation is y equals 1/2 x plus 3. We don't type the y equals, remember, we just do 1/2 x. So Control divide 1 over 2, and then arrow over x plus 3. And then I'm going to arrow down and do Control divide again, because this time I have 1 over 2, arrow over, x minus, oops, I didn't arrow out. Okay, so 1 over 2, and you notice my x was on the bottom, so I didn't arrow out. X minus 2. You want to make sure that x is always out here. So that's 1/2 x minus 2. Now I have both equations. I can press enter. And what's going on here is I have two equations with the same slope, but different y-intercepts, so they will never touch. And if I want to put my dots on my graph, I can hit Control T to get a few dots. Or I could even use my equation. So I know the very first equation right here is 0, 3, because the y-intercept is at the y-intercept is at 3, so I'm going to go 0, 3 right there. And then I'm going to go on my calculator and look at my calculator. And it says another point is 2, 4 or 4, 5. So I'm going to go with 4, 5. I'm going to grab this one. And I'm going to, I just made sure it's in the front in the order. So I did 4 and then up 1, 2, 3, 4, 5 right there. The second equation is 1/2 x minus 2. So I'm going to put 1 point at -2. So if you go to the table to put your points, if you notice here, it goes 4, and the first equation is at 4, 5, but the second equation is at 4, 0. So we're going to put that second dot for the second equation at 4, 0. And of course, because there's no intersections here, there are no solutions.